All right, guys. Welcome back to our channel. In today's class, we want to talk about chemistry practical experiment 4. Please, if today is your first time of coming to our channel, please kindly hit the subscribe button below. Okay. By doing so, you encourage us to do more videos, and not just that. Please um, like the video, and perhaps you can put a comment in the comment section. But please don't forget to hit the subscribe button. Just smash the subscribe button below. Okay, in today's experiment, we is actually experiment 4, and the title of today's experiment is solubility product constant KSP. Right, the objective of this experiment is to determine the molar solubility of KSP of calcium hydroxide, and also to determine the molar solubility of calcium hydroxide in the presence of calcium ion. Recall that calcium ion, when added to calcium hydroxide, will actually play part of a common ion. Okay, so the procedure is already here. The reaction is basically more of a titration reaction. So you're going to set up a burette. Now inside the burette, you're going to be having your HCl acid. Now if you look at this procedure one, they said prepare a 50 ml burette for titration. Rinse the clean burette with tip and tip with 2 5 ml portion of standardized 0.1 molar HCl solution and discard. Now, that standardized simply means that the concentration of the HCl is known, right? Remember, standard solution is a type of solution that has a known concentration. Okay, so the HCl is going to be filled to the burette. You can just read the instruction on how to rinse your burette and get it right. Okay, so let's look at the procedure 2. Recall that every titration must always involve a burette and a flask, right? A burette is mostly where you have your standard solution. In this case now, it is HCl. Okay, now in the flask, we're going to be having calcium hydroxide. Calcium hydroxide is actually assumed to be um, an undissolved. I don't have to put it. Okay, let me put it this way. Now, KSP is mostly used to, it's mostly used for sparingly soluble salt. Sparingly soluble salt is a solid that when it dissolves in water is going to dissociate partially. Calcium hydroxide in this case is not really a salt, but is a solid that when it dissolves in water is going to dissociate or dissolve partially, right? Now, the instruction on how to go about it is well explained in procedure 2, where they said obtain a sample of saturated calcium hydroxide, right? Allow the undissolved calcium hydroxide to remain settled and on the bottom of the flask, right? Without disturbing the insoluble calcium hydroxide, carefully decant. Now, what this simply means is that it's more like you're adding something inside. Let's say you add a salt inside your flask or tumbler, a huge amount of salt, right? Once you've done that, you realize that not all the salt is actually going to dissolve in the water, right? Once the water have taken the ones it's able to take, you're going to actually decant it, right? Discard the solid and keep the liquid that contains the salt. So basically, that's what we are doing here, all right? So the instruction on how to go about it is actually explained in procedure 2, right? All right. Now, you have to record, once you're done decanting it, record the solution temperature. Let me read out that procedure 2. They say obtain a sample of saturated calcium hydroxide. Allow the undissolved calcium hydroxide to remain settled on the bottom of the flask. Without disturbing the calcium hydroxide, carefully decant the saturated solution into a 1 to 5 ml LMR flask. Rinse a 25 ml pipette with 1 or 2 of the saturated solution and discard. Pipette 25 ml of the decantate into a clean 1 to 5 LMR flask and add 2 drops of methyl orange indicator. Record the solution's temperature. Right, full stop. Titrate with standard HCl solution. Record the volume needed to just turn the yellow color red. Repeat the titration for two new samples. Now let's look at the next page so that you understand much better. Now if you look at this, right? The concentration of the HCl, which is this guy, 1 minute. Concentration of the HCl, which is this guy, right? They gave us in the question to be 0.1 molar. But recall that molar is mole per liter. Don't forget that. But here they said concentration of this in millimole per mil. You don't have to worry yourself. I'll actually put us through. Now, the practical has been done before now. So the values I'm going to insert here are basically the values obtained from the previous experiments conducted in the lab. Okay. Now look at the table here. All right. Now this is a table. Please just follow up the video. I'm going to tell us how to start reporting in your manual. So this is a table here. The first trial we have 0.00 and we also have 10.3. So let's come back here. I'll come here. I'll say trial 1 0.00. We have 10.3. We have 21.3. All right. Now for the final burette reading, we have here to be 10.3 for the first trial, here to be 20.3, and here to be 31.8. Now the volume of the acid used, remember what was inside the burette was the HCl. Right. For the first trial, the burette was filled to 0.00. Right. After you must have, conducted the first trial, the color changed from yellow to red. That means you've gotten to your endpoint. Right. You check the volume that has reduced in the burette. It moved from 0.00 to 10.3. You record it here. Now, the volume of the acid used would be final minus initial. So this is still going to give us 10.3. All right. Now, you don't really have to fill in the burette again. You can just continue. Now, the trial 2, the initial of the trial 2 is a final of the trial 1. So this was where the reading was after you stopped the first trial. So for you to comment the second trial, you're going to take the final reading of this guy as the initial of the second one. You do it for the second time, the volume moved down to 20.3 and then the color changed. Now, please bear in mind that in the lab, it's not necessarily going to be the same values. It might be close to these values, cool. But remember, these values were actually obtained from previous experiment being performed. So this year's experiment must not necessarily be 10.3. Please take note of that. Right, so you don't really have to transcopy everything into your manual. This video is just meant to guide us to know what exactly you have to do in the lab. So 20 here is going to give us 10.3. Now for the last guy, 30.8, 31.8 minus 21.3, that'll give us 10.5. All right, so we are done with the first part. Now this part, we are getting it from our titration, right? This part we're getting it from our titration. Okay, this part is obtained from our titration. Now this is a table, right? A full table to. Now where am I going to write this table? Please, in you have to open to your manual. You see where you have data results sheet, right? You open to that place, put down your experiment, your title, right? Please, this is meant to be solubility products, right? It's meant to be solubility products. Okay, it's meant to be solubility products. All right. So you go to your data sheets, put down your experiments, your title, objectives, and then your reading. I'm coming to this now. Let's go back to this table. We've actually completed this guy. This particular 1 to 3 will be obtained from your experiment. Remember, the HCl is actually what is inside your burette. Don't forget that. The calcium hydroxide, 25 ml of calcium hydroxide is inside your flask, right? Now, recall that the main purpose of titration is to determine the concentration of one of the reagents. The two reagents we're making use of in this experiment is HCl and calcium hydroxide. Now, the concentration of HCl is known to be 0.1 from here. It's known to be 0.1 from here. Now, that of calcium hydroxide is what we're going to be looking for in this experiment. But before we do that, there is table in table number 4, they said concentration of standard HCl in millimole per mil. Now, let me take us to somewhere. Let's look at something else here. Now, recall that, let's use red marker. Recall that molar concentration is always mole per liters, right? Now, they are asking me to convert 0.1 molar, all right, to millimole per mil. Now, this is what I'm going to do basically. This is what I'm going to do. I'll say 0.1 molar is always equal to 0.1 mole per liter. I'll draw my line. Now, just follow up and see what I'm about to do here. Is it going to give us the same thing? So this becomes, I want to convert this mole because they're asking me to take this guy to millimole per mil, right? So I'll come here, I'll say mole. I want to convert mole to millimole. I'll put mole down, I'll put millimole up. Now, how many millimoles make 1 mole? 1000 millimole makes 1 mole. So that this can cancel this. Now, we want to convert from liters to milliliters. You put liters here, you put milliliters. Now, 1 liter makes up 1000 mil. So that this cancels this, right? Now, we are left with equals to 0.1 times 1000 millimole. Now, this is divided by 1000 mil. 1000 cancels 1000. So we have 0.1 millimole per mil. So therefore, guys, 0.1 molar is still the same thing as 0.1 millimole per mil. Alright, so you come back here to this your number 4. So here is going to be 0.1, 0.1, 0.1. We are good, right? Now the next question is millimole of HCl added. Now recall that, let's look at this particular guy. Now we say, okay, so let's look at the number 5 where they said millimole of HCl added. Now, for you to really understand or to know how to solve for this, now when they said added, where was it added to? That's the first question you ask yourself. And where is it coming from? HCl was actually inside the burette. Alright. Now it is being added to the flask that contains calcium hydroxide. Now, if you take your mind back to your table, alright, now look at this table. Now this particular guy, the volume of the acid used, alright, please, this is volume of the acid used, alright, this particular guy, this is the first titrate. Now this is volume of HCl used, and this is burette reading final. Okay, now so for the first trial, the volume of acid used is 10.3. So you come back here. So it simply means that 10.3 is a VA for this guy. For the first trial, VA equals to 10.3. All right. Now, what is the concentration of this particular guy? The concentration of this guy is actually zero point 0.1. Concentration of HCl from the previous video, concentration of HCl, all right, is zero point 0.1. Okay. Now, the next thing you're going to ask yourself, let's switch to white. They are asking me for the millimole. But remember, for me to get my millimole, I'll first of all get my mole. All right. So what I'm simply going to do here is going to say, I'll say mole, mole of the acid, which is Na. Sorry, let me. So what we're going to do here is that first, for you to get your millimole, you must first of all get your mole. So I'll say mole of the acid, which is Na, right? This is equals to molarity times volume, right? Molarity times volume. So therefore, Na equals to Ca times Va. Now recall this Ca is 0.1 molar, which is the same thing as saying 0.1 millimole per mil. So you can equally use this zero point 0.1 without bothering about the unit. It's still the same thing. The volume is actually in mil, right? So it is meant to be the volume is 10.3 mil. Okay, so the number of mole of this guy becomes concentration is 0.1. Okay, now this is millimole per mil times the volume here is 10.3 mil. This cancels this. All right, now the answer we have here is 0.1 millimole. Sorry, that's not 0.1 millimole. So this becomes equals to, and we have 10.3 times 0.1. So we have 1.03 millimole. Okay, so that is the mole of this guy. Fortunately, it's already in millimole, so we don't have to convert anything again. So say this is 1.03 millimole. You come down here, this becomes 1 point, sorry, the previous part cleaned off, but is already present in the other video. You don't really need the units. You just come here and say 1.03. Now, I'm not going to solve for trial 2. I'm not going to solve for trial 3. But we are going to, do the same thing for trial 1. Right? For trial 2, I'm going to remember this place was, let's fill this pot at 1. This is 0, 0. This is 10.3. This is 10.3. This is 10.3. This is 20.3. This is 10.3. All right. Now, that last one was 21.3, 31.8. So this is 10.5. Okay. Now, the concentration, this guy was 0 0.1, 0 0.1, 0 0.1. Now, how did I get this millimole? I'll simply say, remember, mole equals to concentration times volume. Right, now since this unit is already millimole per mil, right, I can simply say if you multiply this concentration of HCl times the volume of this, right, 0.1 times 10.3 will give us this. If I do the same thing here, 0.1 times 10.3 will still give us 1.03. This time this will give us 1.05. Right, but you need to show the working. Where will I show the working? Here. Now, so you're done with the first trial. You can come here. You can say um, trial 2. You say for trial 2, the volume of the acid, which is the HCl, was still 10.3, and the concentration of the acid was still 0.1. All right. Now this is molar, which is equivalent to millimole per mil, based on what we've done so far. So mole, which in this case is the millimole, equals to concentration times volume. All right. So this becomes 0.1 times 10.3, and this is 1.03 millimole. All right. So you can do this for trial 3 as well. So once you're done with those guys, come back here and pull in your answer here, which is exactly what we've done so far. So number 6 has been taken care of. All right. Now, oh, please, this is number 5, not number 6. Sorry. This is number 5. It's not the number 5. All right. So this is 1.03, 1.03, 1.05. Now let's look at number 6. Number 6 says the number 6 is actually millimole of OH in the saturated solution. Now recall that the titration had we know the concentration of HCl to be 0.1 molar. They did not tell us the concentration of the calcium hydroxide. Obviously, that's what we're looking for. So once you've gotten the concentration of calcium hydroxide, you do your mole ratios, stoichiometric equivalent, to get your OH. Now, so how do we get first? You have to solve for concentration of CaOH2, which in this case is the base. All right. So therefore, concentration of CaOH2 is our Cb. Right. That's our Cb. Now, remember we have 3 trials. So we're going to do this thing for the same thing we are doing here. I'm going to repeat it for the second and the third. So just pay attention so you understand this. Right? You're asked to solve for the molarity of the mole of OH. Right? But you know that they did not give us OH in the equation. What they gave to us was calcium hydroxide, CaOH. So if I'm able to get CaOH, right, for mole ratio, I'll be able to get OH. Do you understand? So we say concentration of CaOH is equals to Cb. That's concentration of the base. All right. Now, I'll come here, I'll say, this is what I'm asked to find. So for me to be able to solve for this, I'll use CaBa all over CbVb equals to Na all over Nb. Okay. Now, so let's get all these parameters out before we start solving. Now, Cb is concentration of calcium hydroxide. And that is what we are looking for, because if you're able to get the concentration of calcium hydroxide, you now be able to get the mole of the molarity of hydroxide ion, that is the OH. And from the mole, you can now get, from the molarity, you can now get the mole. All right. Now, the volume of the base is 25 mil. Now, how did I get this 25 mil? Recall from this analysis, they had said pipette 25 ml of the decanted, what you decanted from the test tube into a flask, from what you decanted from the previous flask that contains solid particles of the calcium hydroxide, you decanted it such that the new solution now will not have the solid, it's just the solution alone. So you took 25 ml of that calcium hydroxide, so that becomes the volume of the base. All right. Now, number of moles of base, our NB, from this equation of reaction, NB here is equals to 1, because if you notice, this is an acid, this is a base, right? This is a neutralization reaction. So if we check the mole ratio, the number of moles of the acid is 2, that of the base is 1, right? So our NB is equals to 1, right? Now, we are done for that of the base. Now, for the acid, Ca is equals to, recall that concentration of the acid, they already gave us concentration of the acid from this question to be 0.1 molar HCl. And then when we converted this guy to the millimole per mil, we still got 0.1, right? Now, so therefore, the concentration of this guy is 0.1. You can call it molar. Let's say millimole per mil. I can call it molar because the milli will cancel the milli, leaving us with mole per liters. All right. Now, the volume of the acid. Now, this volume of the acid depends on the trial. So, for the trial one, right? The volume of the first acid, for the first trial, the volume is 10.3. For the second trial, still 10.3. For the third trial is 10.5. But since we're dealing with the first trial first, right? So here is going to be 10.3 mil. Number of moles of the acid, right, becomes 2 here. So this becomes 2. Okay. So now what we are going to do now is that we want to solve for this particular guy. So I'll come here, I'll say there's minutes. All right, so I'll come here, I'll say, so therefore, using CA VA all over CB VB equals to NA all over NB. If you make your CB subject of the formula, because that's what I'm looking for, this is going to be equals to CA VA NB, okay, all over VB NA. Okay, if you make your CB sub, for those persons that, please just check it out. If you make CB subject of the formula, that's what we're going to get. All right. We say here we have CAVANB. First of all, cross multiply. Now have CBVBNA. All right. Please, this is actually, let me write it well. Is actually NA all over NB. Right. So if you make this guy subject of the formula, divide both side by VBNA, you're going to have this. Okay. So now let's insert our values here. Please take note. I'm doing this so that you know how to solve this. So my CB will now be CA. The value for CA is 0.1. The value for VA is 10.3. The value for NB is actually 1. Now this is divided by VB is 25 times NA is 2. Okay, so if you press your calculator, this is what you're going to have. You have 0.1 times 10.3 times 1 divided by 25 times 2. Okay, so the answer for here, our CB will now become 0.0206. All right, now this is molar. right? Recall that this molar can still be called millimole per mil, right? So you don't have nothing to worry. You have nothing to worry yourself about, right? So the CB here is 0.026. Now, let's do something. They did not ask us. Recall that CB is concentration of calcium hydroxide. But what they are asking me is the millimole of OH minus, which is okay. So we've gotten the concentration of calcium hydroxide, but remember they asked us to solve for the millimole of OH, right? So what we're going to do first is to convert the concentration of this calcium hydroxide to millimole first. They will now use our mole ratio to get that of the OH. So I'll come here. I'll say convert 0.0206 molar calcium hydroxide to millimole, right? Now recall that this 0.0206 molar is same thing as 0.0206 millimole per mil, because this milli can cancel this guy, leaving us with mole per liter, which is same thing as the molar. All right. Now, for us to actually solve for the mole of this, recall as well that mole equals to molarity times volume. Molarity of this base is CB, which is 0.0206. The volume of this base, that's the one we made use of, right, was equals to 25 mil. So we're now going to say our mole of CaOH2 equals to the molarity of this guy, which is 0.0206, times the volume of this guy is 25. Okay, so say 0.0206 times 25, and that will give us 0.515. Now remember, this guy is millimole per mil, and this is mil. So this mil cancels mil. So here becomes millimole. All right. Now, since we've gotten the millimole of, we now say so therefore millimole of calcium hydroxide equals to 0.515 millimole. But this is not what they asked us to find, right? They asked us to find that of OH minus. They asked us to find that of OH minus. So I'll simply come here and say, so therefore, this is calcium 2 plus 1 is to 1 is to 2. Now the mole of this guy is 0.515. Now this guy is going to be 2 times 0.515. So therefore, millimole of OH minus is equals to 2 times 0.515. Now once you press your calculator, 0.515 times 2 will give us 1.03 millimole. So here, you come down here, this is 1.03 Funny enough, coincidentally, it's giving us this 1.03. Okay, all right. So we've done that for the first trial. So millimole of OH in the saturated solution. Well, so if you look at it this way, it means that if the millimole of the acid added and the millimole of this guy in the solution, that means this reaction was indeed at um, it was indeed a neutralization reaction because they neutralize each other. Okay, so that is how we got this guy. You can see from the calculation here. First of all, solve for the concentration of the CD, that is that of the calcium hydroxide. From here, you actually proceeded to solve for the molarity of this guy. The molarity gave us the mole gave us 0.515 millimole. Now, when you now do your mole ratio, this is 1 is to 1 is to 2. The mole of hydroxide ion is going to be 2 times this, which gave us 1.03. So you can do the same thing for trial 2, right? You can just do the same thing for me. You can even decide not to stress yourself for the trial 2. Trial 1 is enough because when they are marking, once they see your calculation, you're solving and they check the table. So once you've done one of them, I think you can still get your mark. So if you don't have enough space, or you can divide your manual, if you don't have enough space, if you just do one, and then you can use your IQ. This is going to be 1.03 as well, 1.05 when you do your calculation properly, I believe. All right, but please make sure you check this out first before you um, conclude. Okay. All right. So the next one is going to be question number 7. Question number 7 is a bonus mark. You don't need to stress yourself. The volume of the calcium hydroxide solution used, right? The one they took the pipette. Right now, look at it this way. The pipette, they say pipette 25 mil. That's what they're asking us. So the volume of this guy used is 25. Is going to be 25. Is also going to be 25. Now the temperature of the saturated solution, it's always yeah, you assume the room temperature, right? They will also tell in the lab, but in case they don't tell you guys, please, it's 25 degrees Celsius, 25 and 25. Okay, now let's now solve for the the next one. Now OH at equilibrium. Now look at this. Now if you're being asked to solve for OH at equilibrium, this equilibrium is the same thing like what we just did here. The concentration of calcium hydroxide here was 0.0206. All right, so 0.0206. So if they're asking you to solve for that of equilibrium, once you've gotten the concentration of calcium hydroxide, right? So this is what we're going to do. Question um number 9. So say OH at equilibrium. Now at equilibrium, calcium hydroxide, right? We have this. Now this is 1 is to 1 is to 1. Now from this our calculation here, right? It's not this particular one. From this our calculation, we had gotten the concentration of calcium hydroxide to be 0.0206 mole, right? This same calculation is what we are going to use to get the concentration of OH, right? You first of all solve for that of calcium hydroxide. Once you've gotten your answer, you now take your mole ratio. Okay, so this is actually that of calcium hydroxide. So here becomes 0.0206 is going to be 2 times 0.0206. So therefore, concentration of OH at equilibrium is going to be 2 times 0.0206. So this is going to give us 0.0412 molar. And this is for the first trial, right? You're going to do the same thing for the second trial. You're going to do the same thing for the third trial. Remember, I told us that if you want to solve for your concentration of calcium hydroxide, the only difference in the trial, right, is just the volume of the acid that you're going to make use of. For trial 1, the volume of the acid you're going to make use of is 10.3. So you come here, when you're solving for CB, this was for the first trial. When you're solving for CB for the first trial, the volume of acid you made use of is 10.3. But since the volume of the acid in first trial and second trial is actually the same, right, it means that these two guys, this guy and this guy, will obviously be the same. Now, for this third guy now, for you to solve for your concentration of the base first, the volume of the acid you're going to make use of here is going to be 10.5. Remember I told us that understand how I solved the first trial, repeat it for the second trial and the third. But if time is not on your side, you can just replicate what you have in the first trial for the second trial because they're almost the same thing, right? Just do the same thing for the first trial and the second trial. The third trial, the volume, since he gave us 10.5, the difference in the answer will not be much. Okay, so this is a concentration of this guy, right? So come here, come back to this guy. I have my, remember this table is meant to be in your data table. You're going to, this table now, you see it in your manual, you have to fill it out. You don't have to write it inside your manual again. No, there's already this table inside your manual, just fill in this place. So here is going to be 0.0412. And guess what? Here will also be 0.0412. And guess what? Since the volume here was 10.5, don't even stress yourself with solving it. You can just come here and say 0.0413 or thereabouts. You can even use the same thing everything, right? So we are done with the first one. Now let's look at 11. 10. 10 says concentration, calcium ion concentration at equilibrium. It's very simple. Come back here. So come here. I'll remove this heading. I'll remove this heading. So I'll say number 10, concentration of calcium ion at equilibrium. Now look at this. We already have concentration of calcium hydroxide. So calcium ion and hydroxide ion, we're going to get the value from calcium hydroxide. Now the ratio here, is 1:1 here. So here is also going to be 0.0206, right? Just to correspond to what we have here. So I'll say, so therefore, concentration of calcium ion is 0.0206 molar. All right. Now, how? Remember, we've already solved for calcium hydroxide solution using this CAVA, right? We've solved this already, and we got our CB to be equal to this. And this CB was concentration of calcium hydroxide, right? So once I've gotten calcium hydroxide, for me to get calcium ion, I'll get it from here. For me to get hydroxide ion, I'll get it from here. All right. So this time around, calcium ion concentration is 0.0206 0.0206. So come back here to your table. This is 0.0206, right? I'm going to repeat it because the volume is 10.3 here, 10.3, so it's almost going to be the same thing. 0.0206. And I'm not going to bother myself with solving all of this. One solving is enough. So I'll come here, I'll say 0.0206, right? Because the answer may not be 0.206, but it's going to be close to this, right? Because the volume of this guy was high. So for those of us that, like following protocol, the protocol brethren, right, can just come here, can just say, let me just make you guys happy. Put here to be 7. All right. Now the next thing we're going to do is to solve for the KST. All right. So I'll simply say, now I don't want to go far. My KST here will simply be KST, I don't want to go far, equals to concentration of calcium ion into this. Okay, let me remove this guy here. Let me resolve it from this other side. Okay, so let's solve this guy. So let's remove this guy here. I'll say clear this place. So I'll say, so therefore, okay guys, let's look at number 11, the KSP. Okay, so how do you solve for the KSP? Now take a look at this. I already solved that somewhere. Now we have okay, let me resolve that again. Now 11, it says 11 say KSP, right, equals to, remember the equation we are writing this KSP for is this particular equation, right, is this equation. All right, so our KSP becomes, all right, now remember we're going to do this for the 3 trials, trial 1, trial 2, trial 3. Now, but you don't really have to solve all of them for the 3 trials. If you solve for 1 trial, it's okay. Now, because the values, if not going to be the same, they'll be very, very similar. Because if you look at the values we've been obtaining for the trials, it's almost equivalent. All right, so I'll say for trial 1, okay. Now, sorry, trial 1, not trial 2, for trial 1. So you come down here. Now, what you just need is the concentration of this and that of this. Finish. Now, let's look at, for trial 1, concentration of calcium ion is actually, this concentration of calcium ion 0.0206, and concentration of hydroxide ion is 0.0412. Okay, so all we just want to do is that anywhere you see calcium ion, you put this. Anywhere you see all hydroxide ion, you put this and you square it. At the end of the day, you multiply what this answer and the square of this guy to get the KSP for this guy. All right, because if you look at it, the concentration of this guy is 0.0206. That of hydroxide is 0.0412, but you have to square it. So this answer is going to be the same thing as this. It's almost going to be the same thing as this. All right, so just write, once you solve for the first one in your manual, you don't have to solve for the second guy, except you have enough space to do that. Just put in the answer here, put it here, put it here. All right, so let's dive into it. So I'll come here, I'll say this is 0.0206, and this particular guy is 0.0412. 0.0412. All right, so therefore my KST will now be equals to, right, this is we have this. Okay, so anywhere I see calcium ion, I'll put 0.0412. 0206 times hydroxide ion is 0.0412 all squared. So when you do that, you're going to have 0.0206 times 0.0412. So this becomes 3.49 times 10 raised to the power of minus 5. Okay, so where are you going to record this? Come back to this guy. So you can see the KSP here. So we're going to put here 3.49 times 10 raised to the power of minus 5. The same thing is going to be here because the values are the same, right? 3.49 times 10 raised to the power of minus 5. The same thing here, 3.49 times 10 raised to the power of minus 5. All right. Now, before I proceed, talking about the next one, class, after this calculation, this particular practical has this calculation part we are doing and also the question and answer part. The question and answer part, right? I'll drop it on the comment section, but it's just for people that have gotten to this stage. All right. So if you've gotten to this stage, right, just comment on the comment section. Please share the solution B. I'll share that. I'll be sharing it to each other's inbox and DM, right? I just more like to compensate people that have gotten to this stage. So once you've gotten to this stage, once you're done with the video, go to the comment section. So there was a please, I need the question section B, question and answer. I'll reply you and send it to your inbox directly. All right, in your YouTube page, just on your YouTube, just come down to the comment section, say, please send me the answer to this. I'll send it to you directly. All right. Now, for us to get the average of this guy, all right, the average simply means add up this whole stuff and divide it by 3. So apparently, it's still going to give us the same thing. But for the to show them that you actually did it, right? Just come here and say can just say average KSP equals to 3.49 times 10 is to the power of 5, although it's not necessary, but you can just do it to make your work look so neat and well coordinated. Now this is divided by 3. You're going to now have 3.49 times 10 is to the power of 5. Still the same thing, all right? Now, so you now come back here. The same thing here. 3.49 times 10 is to the power of 5. The same thing here, the same thing here. And there you go, you get your answer, all right? Now, for this number 13, the answer you're going to get as number 10 will be the same thing as number 13 because the same molar solubility of this. Molar solubility in this case same thing as molar concentration. And if you do this, calcium hydroxide, if this guy should dissociate, you're going to have calcium plus 2OH minus. This is 1:1. Alright. So whatever the concentration of this guy is, that will be the concentration of this. And we already solved this guy number 10. So the molar solubility of this guy will now be 0.0206, right? 0.0206, 0.0206. And that's it. You get your answer. All right. Please, if you've gotten to this point, well done for your tenacity and then your how will I put it now? Your resilience. Okay. Please hit the subscribe button to at least to encourage us for making the video. It has not really been very easy. All right, sitting in one place to make this video, just in a way of appreciating us. Please hit the subscribe button, like the video, and please drop a comment on the comment section requesting for the section B answer, which I'm going to reply you with the solution. Thank you very much. All right.